Right. So, as usual, we are recording this session. Everybody, welcome to the Beers with Cloud Engineers session 4. Today is June 23rd, and we are going to be talking through a whole bunch of stuff that is forward-looking statements, that is kind of, deep dive into the product and technology. So, don't go out and make any stock purchasing decisions or anything like that based on any conversations that we have today. This is just purely informational session only. And again, super short agenda. We try not to be too formal here. This is really more about the technology and bringing you guys up to speed. So we'll highlight kind of why we're here, who we are, and then we'll dive into the Cloud API updates, which is the primary conversation for today. But we also have a little bit of a conversation we want to add in around some of the change capabilities within event-driven discovery that we're looking at as well. All right, so why are we here? The goal of this is always to make sure we're bringing together you guys to talk about where you're at in your cloud native journey and how you're utilizing ServiceNow to manage that cloud native technology portfolio and kind of where you're going to next. And a big portion of that is us talking about, hey, here's the new technologies and the new capabilities that we're releasing, but a lot of it also is just conversations around, what you guys are doing and what you're having success with. So who we are, if you don't know yet, if this is your first time joining us, my name is Mike Gallagher. I'm an advisory solution architect here at ServiceNow. I've been in IT for far longer than most people would assume, but 25 plus years I've done everything under the sun, but really now my primary focus is around cloud native technologies and how it all plays with ServiceNow. I think a lot about Kubernetes, a lot about containerization and where we go. As I tell everybody, I have a propeller head and I love to use it to solve business problems. Will?
Thanks, Mike. Welcome, everyone. My name is Will Hallam. I'm an advisory solution architect for ITOM at ServiceNow. I've been here just over a year. Before that, I spent about 6 years working at a ServiceNow customer where I found ServiceNow was a great platform to help me automate a lot of cloud management and on-prem infrastructure management activities. And it's been exciting to kind of show other people ways to do that using our platform. And my spare time, I love to hang out with my family, play a little pickup hockey.
All right. So let's get into the meat of why we're here today, right? The whole goal today is, as of 1.0.90 of the discovery and service mapping patterns, we've released the ability now to essentially do automated discovery of Kubernetes clusters against GCP and AWS. And in July, which we'll kind of dig into a little bit more, Azure will be an option as well. And the whole goal behind this, and we'll dig more into it in a minute here, is now you won't have to manually create schedules, serverless discovery patterns, and credentials for every single Kubernetes cluster, right? It'll be, hey, you can figure out the appropriate things for the cloud provider itself, and then everything else kind of takes care of that beyond that. So that being said, I'll go ahead and let Will kind of dive in from here.
Awesome. Thank you, Mike. So as Mike alluded to, we've now got support for automatic Kubernetes cluster discovery schedule creation driven out of the various cloud providers' Kubernetes as a service. So for those of you who haven't had the enjoyment of discovering Kubernetes clusters up till now, it involves a series of steps for each cluster traditionally. And so for one or two clusters, that wasn't really a big barrier to entry. But the feedback that we got and that we encountered ourselves, if we tried to scale that up in our lab environments, was it can get a little tedious to have to go through those steps over and over again. And so based on that feedback, our pattern development team has put together enhancements to the existing discovery and discovery patterns store application. So that was made available in May. And as Mike alluded to, there's an update coming in July. I believe it's late July, around the third week of July, which kind of rounds out the power trio of cloud providers. So today, we're able to, as part of native Google Cloud and AWS Cloud Discovery, detect when there are Kubernetes as a service clusters. And so what that means is if you're in AWS, it refers to EKS, and if you're in GCP, it refers to GKS. If there are Kubernetes clustered provisioned in a cloud account which is being discovered, some basic table entries are created in the Kubernetes cluster CMDB table. And then after your cloud discovery completes, or after that pattern completes within your cloud discovery, a postscript runs, which then goes through those clusters that exist in that Kubernetes cluster CMDB table and generate a discovery schedule for each one of them. And the need for credentials is also deprecated for that particular flow, because there are cloud API calls which can dynamically provide temporary credentials that Discovery can then use to discover the cluster. And so what's happened is there's code behind the scenes that is now pulling out temporary credentials using the appropriate cloud API call and feeding those into the standard Kubernetes discovery pattern, which then runs against those clusters. So in this in the deck, you'll see at the bottom of that last slide, there's and we'll send these slides out after the webinar. There is a knowledge base article on support.servicenow.com, which should be visible to all customers at this point, and that's a kind of a critical piece that currently is basically errata from the documentation, where it fills in a few blanks that are currently there in the stock documentation that talks about setting this up. And that knowledge-based article is pretty pivotal because it also includes an update set that has to be applied to any instances that are not running Tokyo or newer. Starting with Tokyo, the requisite global objects will be included, but since this was rolled out with support for Rome and up, if you're running Rome or San Diego, then there's an update set that needs to be applied in order for this discovery mechanism to function correctly. All right, next slide. So the next two slides are really just for reference. We've captured the different pieces that either were added or modified in order to support this. And we just felt it was kind of important to do that because this is kind of a technical, this is a technical forum, and we just wanted to kind of provide transparency. And also, if you're trying to set this up and you're running into some kind of a hiccup or an issue, these next few slides show you kind of all the pieces that are involved, all the moving parts. And I kind of had to discover this myself as I was kind of setting it up for the first time and working through a few hiccups. And so this is a really useful list to have because it kind of follows the whole process and shows you every piece of content in your instance, which is doing a piece of this functionality.
Yeah, the key point there, the mid-server script includes, that's where it actually goes and runs the credentials gathering process for each of the cloud providers when it does the Kubernetes discovery. So you'll notice that it has requirements in there for the AWS CLI to be installed on your mid server, as well as the Azure CLI or the G-Cloud CLI, if depending upon which cloud provider that you're on. So that's a key point to be aware of and understand that those scripts are actually getting pushed down into the mid server and they're executing locally on the mid server so that they have the necessary permissions.
Okay, let me clear out my little circle there. And you know what? I got so caught up and excited about automatic Kubernetes discovery. I forgot to open my frosty beverage for the day, which is Daisy Cutter Pale Ale from the Half Acre Brewery in Chicago. So I'm going to just kind of open that up here. Also, I was remiss in popping up our introductory poll just to kind of get a sense of the room. It's got a couple basic questions, just trying to gauge where everybody's at in terms of their journey to cloud native, specifically related to Kubernetes. It's just selfishly, that's kind of one of the reasons we started this series, was just to get more in touch with ServiceNow customers who are, somewhere in the journey to cloud native, and find out what they're doing, what matters to them, what's difficult, what's easy, what lessons have they learned, so that we can try and use that feedback loop and feed it all back into the platform and improve it.
Yep. Yeah, this information here will actually help us kind of talk to the product team to help them focus their work on where we're developing patterns and what should we kind of work on next. So this is important, and I appreciate you guys sharing. Okay. So while we're doing that, Will, do you want to kind of walk through the flow and what this looks like?
Yeah, let's do that. So the flow that you see diagrammed out now is representative. It was specifically initially created for the GCP pattern, because that was the capability that got developed first, and then the Amazon and the Azure capabilities were kind of built using the same cookie cutter approach. So the same general flow applies, even though this specifically calls out some Google components. So let me get my highlighter back here. So it all starts with this pattern. This is a new pattern that was introduced, and there's one for each of the big three cloud providers, called the Kubernetes Discovery and Schedule Creator. And at a high level, what that does, and for those of you who are curious, if you update your Discovery Patterns app, you can, like any other pattern, you can click into it with Pattern Designer and see exactly what it's doing. You can bring up a pattern log and see, the steps that it's going through and what's returned back. But it basically looks at, it pulls down a list of Kubernetes as a service clusters for the particular cloud provider, and puts a stub entry consisting of some basic information like the API endpoint, the cluster the Kubernetes UID, if that's provided by the cloud provider, the IP address for the API endpoint. And then once that information is collected, this pre-post script, which is also, you can browse to this within your instance once you're at the appropriate level of Discovery Pattern Store application. This iterates through those and then makes API calls to configure an appropriate discovery schedule, which invokes the standard Kubernetes serverless pattern and passes it the parameters which were detected in the first step up here, most notably things like the API endpoint. It populates some new parameters that, if you're familiar with the Kubernetes pattern, you might not have seen until recently, such as the cloud provider that the cluster lives on. And that's where, when the discovery actually runs, that's how the discovery pattern for Kubernetes knows, oh, this is an AWS hosted cluster, so I need to use the AWS CLI to extract the appropriate credentials. And so, yeah, the steps continue. This refers to the code that was written to actually make the API calls back into the platform to create those discovery schedules. And there's code included. It's pretty robust. If the schedule already exists, obviously we won't create a new one. If a cluster comes back as absent, so cluster was deleted from the cloud, then these steps here will take that into account. And if it's marked absent, there's actually a business rule which will take the corresponding discovery schedule and deactivate that discovery schedule. And then the rest of the flow just kind of reflects how once these schedules are set up, they run independently just like any other discovery schedule. They all run in parallel, and they use the standard out-of-the-box Kubernetes pattern, which just has some slight tweaks made to it to accommodate the hooks that are coming from the automated framework versus being set up manually. And all of those result in a more richly populated CMDB.
So why don't we end the poll and talk about the results, and then we'll jump in and have you actually show it in your environment, Will?
Yep.
Okay. All right, so you guys should have had the poll results pop up. And it's really interesting to see we've got a really great mix between, kind of size and quantity of clusters. And then also a significant mix around where your Kubernetes clusters are deployed. I'm honestly a little shocked to see so many of them are on-prem right now. That's actually really cool. I think a lot of the I think a lot of the cloud providers are doing a really good job, but it's still nice to kind of have a hand-rolled cluster. And then how are they built, right? Build them yourselves is pretty small number, and I'm guessing that's even a subset. Looks like that's even a subset of the on-prem folks. But there's also a pretty significant number of kind of curated, where it's open source, Tanzu or Rancher. So that's really, really good information. And I think what we may do is ask some more questions, maybe in the next session, to dive into more around that curated support stack and hear more about which ones of those you guys are using, and if you've had any specific questions or concerns. So thanks. This is really great information. Very cool. So why don't we go ahead and jump into the deep dive. I'll stop sharing, Will, and you can throw up your instance and kind of walk us through it.
Sounds good. All right. Okay, so I've successfully set up and exercised both the AWS and the GCP option. I'm going to start by showing the AWS scenario because it was a little more involved in terms of the AWS side of setup to make sure that your discovery, that the mid server doing the discovery had the permissions required to query the Kubernetes cluster. What I found with GCP was it just seems to it seems to just kind of work more seamlessly, whereas with AWS there were a couple additional steps to basically assign a role to the mid server and then map that mid server role to basically to a user in the EKS cluster. So kind of start off with that, because that was kind of the first time I put it together, I was getting all kinds of permission errors, and then had to kind of walk through just a couple extra steps to get that sorted. But if I can save somebody else the time of having to kind of discover that on their own, all the better. So what we're looking at here is my AWS account. I've got my one of my mid servers here, which I've chosen for this task of Kubernetes discovery, and I've assigned it a role that I just called sn-mid. And then when I drill into that role, this is a lab, so I wasn't, didn't want to really get into too granular permissioning exercise. So I just gave it view only access for the account, which I use it to discover other cloud assets. So it was really, applicable just so that it could discover the entire account. And then, so the piece that kind of gives that relevance to my EKS cluster is using EKS cuddle to map that. Let's see. to map that role into a Kubernetes user. So here's one of my, I'll just kind of run that against one of my clusters. And so this just dumps out the IAM identity maps that I established for this test cluster. And you can see this second one here. It takes the ServiceNow mid role and maps it to a username named ServiceNow-discovery. And so then to kind of round it out, I deployed this read-only cluster role, which is fairly simplistic. It just gives get, watch, and list against a whole bunch of API groups. Full disclosure, I probably didn't need to put all these in, but I just kind of tried to, I went a little overkill to just avoid having to debug a bunch of granular permission issues. And then the last piece is a cluster role binding, which basically says I'm going to take that read-only role and assign it to, whoops. Let's cat out the actual file. So it basically says, okay, I'm going to take that read-only cluster role and I'm going to assign that to my ServiceNow discovery user, which is the username that I mapped into my role. So that was the documentation kind of says conceptually that's what you need to do, but it doesn't really include an example. So I had to do a little trial and error to actually determine, yes, that's what they actually meant, and to get that working. I actually did also stick that in a quick community article with the step-by-step on how to set up AWS so that you could auto-discover Kubernetes clusters. So I'll include, when we send out the slides, I can include a link to that, because it's kind of useful sometimes to see to see an example and follow along, as opposed to make it up from scratch. So that's really all of the extra work that's required. If you don't have cloud discovery set up at all, then you do need to set up standard cloud discovery for AWS. This methodology does essentially require that you have a mid server running that has the ability to assume or have an AWS role. So every once in a while we'll get a question, hey, can I discover AWS with a mid that's on-prem or somewhere else? And it is possible in general, but specific to get this stuff to work, it really should be a mid server that exists somewhere in AWS. It doesn't have to be in the same account necessarily, it just has to have the ability to make AWS API calls under the auspices of an EC2 permission profile, an EC2 role. And Mike actually alluded to this earlier, but just to reiterate, you do need the AWS CLI, not the PowerShell tools if you're running a Windows mid. It's got to have the AWS CLI installed, because under the covers, it's actually making calls to the AWS CLI to extract the permissions that it needs to talk to your Kubernetes cluster. In terms of what you need on your instance, by default, this is not turned on. There's a property, this property right here, and this is covered, extensively in the documentation, as well as that knowledge base article that will I'll send the link out to. Well, the link to that is in the slides. This property right here is what turns on that capability. So it's got to be set to true in order for your cloud discovery to attempt to generate those automatic Kubernetes discovery schedules. And so I've got that set to true. The other thing that's a must set is you've got to define at least one mid server that is going to actually perform the Kubernetes discovery, because that gets populated when the pattern goes through and generates all of those Kubernetes schedules. Now in addition to these kind of baseline properties, and this is covered in that knowledge base article as well, you can set different properties to point, for example, different cloud accounts at a different mid server for discovery. So for example, I took my default one is pointing to my AWS mid server, but then I defined a second property which is tied directly to my Google Cloud account, project. So you use the project ID for GCP. And so that's basically telling, hey, to discover Google Cloud, use this mid server, which exists in the Google Cloud. And so with those properties, those baseline properties populated, and this one especially, being set to true, if we look at our discovery schedules and kick off just a standard AWS cloud discovery. So I will kick that off. And while that's running, I'll just go back kind of cooking show style to a prior run to illustrate what the output looks like. Whoops, that's the wrong one. So here's the discovery status line for that new pattern, the Kubernetes discovery and schedule creator. And it's a fairly, standard pattern log, if you're familiar at all with the format that discovery patterns use for their log output. And I can just kind of see, yep, it's completely happy. Nothing turned red, nothing turned yellow, got all the way through. And then down at the bottom here, we can see where it's running the post-processing script, which generates the discovery schedules. So one thing to call out is the out-of-the-box solution generates a schedule, an automatic schedule for the Kubernetes pattern only. And if you look at our documentation where it talks about the manual steps involved with discovering Kubernetes, it actually tells you to create two schedules. One, which is suggested to run daily that uses the Kubernetes pattern, and one which runs more often. I forget what they kind of recommend initially in the documentation, but I think it may be as frequently as like every 10 minutes, which uses a pattern called Kubernetes event. So that pattern is intended to be more lightweight. So if you have a really large cluster, it doesn't enumerate and walk through all of the objects within the cluster. Instead, it pulls down a list of recent events and then specifically filters out looking for things like pod destroy, pod create, adding a node, removing a node, that kind of thing, and updates the CMDB based on that activity. So that's not currently scheduled automatically because the concern was that if you've got a lot of clusters, that would result in a lot of schedules running on a fairly rapid basis, and that it could potentially produce scaling issues. So I kind of went off and did my own what if exercise just to see what would be involved with taking the existing out of the box pattern, just kind of applying a couple tweaks so that it would also generate an event, a schedule using the event pattern. And it didn't take much. I'm planning on kind of putting out an article just saying, if you want to do this, here's an example of how you could go about it. It's just, you really have to be cognizant of what your Kubernetes footprint is and how many discovery schedules do you really want to have running at the same time. But it did seem like it was a worthwhile exercise, that there could be a use case where that would be valuable, and having those automatically generated would be useful and save somebody a lot of effort. So it is, it's not there out of the box, but if there's interest in doing it, it's not a heavy lift to make that happen. Okay, so our most recent discovery is completed. I'll just kind of verify that that's happy. And yes, if it had failed, you'd have a failure over here. So let's just go back to the discovery schedule page. And so now, if I pop over here to my account, you can see I've got 3 EKS clusters. And now I've got 3 discovery schedules created, 1 for each of those clusters. And I'll just pick this one. I'll kick it off. While that's running, I will just kind of show how it populated the parameters for the serverless discovery pattern. So it basically, built all of this within using API calls, using the information that's discovered and placed in that Kubernetes cluster table. So it kind of applies a naming algorithm and populates the URL for the control plane, and then populates a provider flag for the indicating, which cloud provider it is using. And the credential alias and Prometheus URL aren't required. There's a property, you can set a property either at a cluster level or a global or a default value for a Prometheus URL if you've got Prometheus running on the cluster. The credential alias is completely not required because it just pulls it out dynamically from your cloud provider. This is a pretty small cluster, so it wouldn't surprise me if this discovery had completed at this point. Let me just take a look. So it applies, there's also properties you can use to kind of control the timing. By default, it basically schedules the initial run for 5 minutes after 5 minutes from the current system time when it creates the schedule. So it looks like it actually kind of ran it twice, or maybe one of them, yeah. So it actually ran them twice. By default, it schedules it to run every day. And so the one thing of interest in the logging output is if we look at one of the steps where it actually tries to pull down some information like get namespaces. So you can see it called out right here in the logging, hey, I'm using AWS CLI to grab a bearer token. And so it grabs, this is part of the output. It's not the full token, it's truncated. And also by default, those tokens are fairly short-lived. So it's basically it's using the cloud API to grab the credential it needs, and then you can see that it's kind of, here's a an example of the payload that it's pulling down, where it's pulling down the list of namespaces, and it just kind of goes on down the list, hits all the specified API endpoints, pulls it in as JSON, parses it, kind of the same way that the Kubernetes pattern's been functioning for a while now at this point.
One of the things I think that's interesting about this is, one of the standard best practices is rotating those credentials on a fairly regular basis, which was very difficult to do in the older method for discovery, right? Because we had to have that managed manually within the ServiceNow platform. So having this kind of triggered and in near real-time basis means that credential rotation is a lot easier to do and is less likely to impact your visibility into the clusters.
Yeah, I mean, there really should be no impact as long as all of your, in the case of AWS, and it's similar in the other providers. You basically have a role assigned to your mid server. As long as those permissions are there and you maintain that mapping, if you have to, like you do with AWS, where the cluster sees that role as the corresponding user with read-only access, really don't have to manage credentials at all. It's really that's a really big plus, I think, for anybody who's trying to do this at any kind of a scale. And so, yeah, so here's our Kubernetes cluster table. We've got a cluster entry now for each of the clusters that was discovered. And really, I mean, the discovery behavior is identical to what the previous iterations of the patterns provided. The main the main difference here is the fact that the schedules are not having to be maintained manually anymore.
Actually, there's one tweak that I think is actually quite nice. Is when you're looking at the clusters now actually ingest the cluster UID as well, which is something that the out-of-the-box pattern didn't do prior to this update.
Yeah, you're right. That is pretty awesome that they're doing that now. They also kind of took the opportunity to give some more meaningful names to the clusters. Sometimes the Kubernetes cluster naming that it populated in here was non-intuitive, and it made it hard to because of the way it was truncated. Sometimes it was hard to actually see which cluster you were talking about by just looking at this list. And that is also, I think, improved with this setup. Any questions? Okay, I'm gonna have another drink of my beer and stop sharing, and you can. Oh, sorry.
Well, this is Vishal from.
Hi, Vishal.
Hi, how are you doing?
Good.
So have this thought, right? So we are mostly on-prem at the moment. Would be promoting our on-prem to AKS. While we are on-prem, is there a better way to manage the credentials? Because I'm having to manually import the credential records, create credential alias, and tie to the individual schedules that I have, because I kind of cascaded them to run one after the other versus all of them being triggered. Because when it triggers all at once, I mean, it just picks up, and that's another issue. I have a case open at support. When you trigger a discovery on a cluster also, with the hard-coded MIT on there, it picks up whatever MIT it wants to pick up from there. And it, I mean, we have a couple organizations in there. We don't want it to pick up some we want to pick up and also want to use a cluster. So that's one thing. But then also to manage the credentials is another thing for on-prem. Is there a way we could do some innovation to managing the on-prem credentials?
There definitely are a few options. So are you managing those on-prem clusters with Rancher, or is it some Rancher and some not Rancher? So
all Rancher.
Okay. So as Rancher's been coming up in more conversations and more over the past several weeks and months. So Mike actually just spun up an instance of Rancher in one of the lab environments. So we're kind of actively looking at some options because it came up. Another customer kind of asked a question about, could they consolidate, provide a single Rancher, kind of what you guys were trying to do, right? Create a single Rancher level credential, which Rancher would then kind of proxy over to multiple clusters. So you wouldn't have to maintain those multiple credentials. So that's something that we're kind of actively looking at. We're also, I mean, as Mike alluded to, that's one of the reasons that we asked the questions in the poll, is to try and bring back, feedback to the business unit that's responsible for this pattern code, to say, hey, we've got X number of customers who are saying they're using Rancher and they'd like more robust support for it in the pattern.
Yep.
So we're kind of trying to push that. In the meantime, the other customer who is running Rancher, they actually came up with a pretty ingenious solution. It's kind of like, when life gives you lemons, make lemonade kind of thing, where they just created an automated import where they just store their credentials and their cluster URLs in a spreadsheet. upload the spreadsheet, and then from
that's what I
there,
did.
there's an automated import that goes and populates the requisite records, which obviously
Yeah,
that's
that's
not,
exactly what I did. I
Yeah.
wrote
okay.
some code. I wrote some code. We had some 60 to
You
load
did.
in. So I kind of
Yeah.
imported that and then wrote some code to create everything automated. It was creating 60 plus, or actually 100 at the time when we started, and then kind of
Yeah.
reduced to 60. But yeah, doing
Yep.
those manually would have been a bummer. And then another question or another issue that I was talking about that I have on the high portal side is about, so I have like a mid server that I want the um,
I
discovery to
saw
go
that.
in
That's
with.
very weird. So
Yeah, keep
it's actually just failing over and trying to use a mid other than the one you're specifying in your schedule.
Yep, yep. So
That's
initially
weird.
I thought, right? So I had like a mid that is tied to a schedule, and then I had multiple execution patterns
Hmm.
tied to the same schedule. So all of them triggered parallelly. So I
Hmm.
thought since they are being triggered parallelly, that's why it's trying to pick up whatever mid. But
Hmm.
then when I tied one schedule per one execution pattern per schedule, and then
Hmm.
when I triggered that, it still exhibits the same behavior, which is very
Yeah.
weird. And also, it doesn't let you select like a cluster. If I were to have like a mid server cluster that I want to select and then trigger something, so maybe I could do like a schedule with multiple execution patterns, and I
Yeah.
could use the cluster, so it could potentially, utilize everything that's in that cluster.
Yeah,
Yeah.
that's an
I
interesting
mean, that
thought.
definitely doesn't sound right to me. I
Right.
did look at that case. I'll have to put myself
Yeah,
on the watch
I'll send
list
you the
for it.
case number. I'll send
I,
you the
I
case
will.
number.
I will also mention I have seen that behavior at another customer. So I don't think that is limited specifically to your environment,
Right.
and that's something that I raised as part of that case as well.
Great. I'll send you the case number just in case both of you guys
Yep,
know.
please do. Thank you.
Will do.
So I want to hit Jason's question really quickly, and then I want to make sure we have a chance to talk about. There's one other thing that we want to kind of squeeze into the schedule today because I think it might be worthwhile. So Jason, do you want to come off mute and kind of give us a little bit more detail on why you don't want to get any of the ephemeral resources?
So we just did a little engagement with AWS and kind of with our security teams, our cybersecurity teams, and we weren't finding any value in collecting all these ephemeral assets. We churn through sometimes 50, 60,000 pods in a day.
Okay.
And there's just too much churn in there. And it's like no one's using them to associate a chain, incident, problem. So it was like, why collect them, right? Why waste all these resources collecting them? They're just going to age out. No one's ever going to use them. It's filling up the table. It takes forever to load the forums, with all the relationships. So
Right.
we decided that we really only want to collect the clusters. Um, there are some tags that are part of the pods that we want to collect because it kind of gives us our app relationships. So we'd still like to take those pods, collect them, and kind of apply them back up the cluster level so we can service map them still. But then really the only information we want for changes is like the YAML file is like what's important for like our change team, right? That's what is doing the deployment. That's what they're specifying what is changing. So really, if we can collect that and the image that then is associated with the pods, that's
Yeah,
kind of
that's
like
interesting.
really the only parts of the environment we want to collect.
How do you what do you tag the image to without having a pod to associate it to? Right, you're sort of like because generally the way the data model works, right, is you've got your services, right, and I could see, okay, look at the tags on the services that are being ingested and use the services to service map, and then not worry about the pods underneath those services, right? The Kubernetes services.
Yeah, from my testing, yeah, we didn't actually have to tag the actual images themselves, right? It'll just be pulled in via the relationship rules.
Right. But if you pull the pod out and
Yep,
then you
exactly. We would
stop,
kind of lose that. Yeah, we lose that middle component. So now we got to create a new relationship back down from the
yeah,
cluster to the image, right?
Yeah, I mean,
yeah,
that should be doable. I mean, my initial thought is you could definitely do it.
I've done it manually. And so
Yeah.
how to get it in the pattern now,
Well, and
right?
I mean, the pattern designer lets you turn steps on and off.
Mm-hmm.
So you could definitely go into the pattern. So the one thing about playing with patterns is I've learned that there's a lot of value in creating your own copy as opposed to tweaking an out of the box pattern, because as soon as you touch an out of the box pattern,
Mm-hmm.
it doesn't get upgraded when
Yep.
the store app gets upgraded. So it is, I mean, you can certainly just back it off and revert it to the out of the box, and then it'll upgrade okay. But so just lesson learned that I've had is it's definitely, there's some value to just creating your own copy and then tweaking it. But you could disable the step that populates the pod table. You might, you kind of said, you may have to create a new relationship, because if it's relying on like container image goes to container, and container goes to pod, and then pod goes to cluster.
Oh yeah, it goes directly
Or maybe node. So you just have to see, like, if that relationship breaks, you might have to add a step that says create a relationship between the container to the node or the cluster.
Yeah, and I've been working on it. I guess my experience with the pattern designer itself, I don't have the most experience there. So I mean, I'm working through it. I've got it to dedupe all my annotations from the pods that I want to collect.
Nice.
Now I'm just trying to get those to apply in the key value table, so I can apply them at the cluster level, and then work on creating the relationships. It's just how it goes when you're learning and iterative process. Yep.
It's gonna take a lot of wax at it until you get it figured out quite right.
Yes, exactly. Yep.
Yeah. That's good feedback though, because like you said, with a rate of change that high, there's like pretty much negligible value in trying to capture all those pods in a table, right?
Yep. And if they need to do any research, they're going to go to the cloud native tools, right? They're going to like Divi Cloud and stuff like that, right? Where it's got all the really details, right? And it's pretty much real time for them if they want to get those pod level details.
Yep.
Yeah.
Or maybe even to Splunk if we're ingesting them there or something.
Yeah.
It's just ServiceNow's really the place for them. At least
although with the new directions that Mike's going to kind of talk about, it's early days, but that's one of the challenges that they're looking to capture, is make it more responsive and give you that like real-time view in the CMDB.
Yeah. So I'm going to run through this really quickly because I want to make sure we have time for more questions, but also I want to get kind of feedback and thoughts on it. So the pattern team is looking at how do we redesign event-based discovery, right? So the issue is right now we have to run those event-driven schedules, and it's hitting the API on a semi-regular basis. And in addition to that, I think I got my slides out of order. That's okay. In addition to that, we have the potential to sort of not only overload a mid-server that's trying to ingest that data, but also if we have a massive cluster that's got a lot of rates of change, we can overload the cluster itself. So the idea is to actually write a Kubernetes informer that actually runs as a background process that then pushes the updates using watch capabilities up into the mid server, right? And so as we start thinking about that, there's a couple of really good things about that. One, it caches the existing state of everything, and then it has it basically is push based from the API itself. So full state comes in initially, and then it's synced periodically using the Kubernetes API that does a push, and that's then fetched using what's called the watch API. And so on the ACC agent, the full state is sort of maintained in memory, and then we can actually take that information and then push it up into the CMDB in order to do those updates in a much faster, much more real-time basis, but also in a way that's less heavily loading on both the cluster and on the ServiceNow instance. So the idea initially is we have a mid server that's running containerized inside the cluster, and there's an agent on there, and it's got a check in the background that uses the client Go program to do that informer connection, right? And then it'll use a watch only against the specific relevant resources, right? Workloads, pods, services, replica sets, and nodes. Notice we're not doing config maps or any of the other components there. And then that will have a kind of a once a minute batch between the Kubernetes API and that informer process that will just send, hey, here's the updates. Hey, here's the updates. So it'll be much more lightweight updates. The other thought process is we could use the ACC agent itself with inside of the cluster, so then we don't need to use Kubernetes credentials to do that. And so a couple of things. One, the team is actually looking for a customer who would be willing to be a design partner with us on this and actually do some testing on this, deploy it in an environment that has a fairly high rate of change that we would feel comfortable ingesting data from, and help to really polish this up so that it can be ready and as soon as humanly possible. So one, we wanted to get thoughts on, does this make more sense? And two, feel free to reach out, raise your hand, send us an email if your organization would be interested in being a design partner and working together on this. So thoughts, questions, or concerns? Okay. That being said, we've got 5 minutes left in our normally scheduled time. We always run a little over, just kind of taking questions and shooting the breeze. So at that point, everyone should have the ability to unmute themselves if they want. And we can, hang on a second here. We can go back to just chatting and talking about what's going on in your environment.
And while we're ruminating on that, I'm going to stick up our exit poll. If folks could provide us with some closing feedback at their convenience, that would be appreciated. I have yet to see if there's any way to include like a free-form text field in a Zoom poll. If anybody knows how to do that, feel free to let me know. But in the meantime, our emails are on the slide deck. You'll see if you got an invite, then that came from Mike's email. So if you have suggestions about topics to cover, or just questions to address, it doesn't have to be like a full-blown topic, just anything kind of in this overall area. I mean, we're focused on Kubernetes, but really we're all about all the cloud native stuff. We're doing a lot with open telemetry now that we've acquired Lightstep. Cloud functions, Lambda, Azure functions, that kind of stuff. Really, we're all about all the cloud native stuff. So anything in that arena is fair game. Feel free to drop us a line, and we're trying to make this useful for you folks. And so if you have feedback on how to better do that, we really welcome it.
Yeah, I'm just going to get some quick feedback. I think this is a really good step in the right direction. I know previously it's been a couple of years since I set up Kubernetes discovery against our AWS cloud, and some of the Kubernetes upgrades over the time broke it when they started adding more metadata into the response bodies, and just setting up and managing all the cluster information. We had to work with their team to provide API access into our platform, and they were sending the keys in and updating the keys in our credentials. And so that was interesting. This is a really good step in the right direction to do this automatically. One quick question I was just going to ask is, from the discovery perspective, does it care whether or not it's using EKS or, a hosted Kubernetes environment within, just on EC2 and whatnot?
Yeah, it's specifically hitting the EKS API endpoint. So if you've got like just EC2 instances that you've spun up and then you've put Kubernetes on those, it won't, that pattern won't pick them up. The standard server pattern will probably pick up your container runtime, But that's an interesting, Mike, do you know off the top of your head, if we run like we're running a horizontal discovery against a server, do we detect, hey, it's running Kubernetes?
No, but if you're running the Docker engine as your
It'll pick up the Docker engine and
but
it'll pull in the containers, but I don't think that it'll say, oh, this is a new Kubernetes cluster. That's an interesting, I'm just make a note of that.
Well, I think, before we had this capability before EKS was really, I guess, formalized, right?
Sure. Yeah.
The Kubernetes teams that were hosting in cloud would open up, the ingress so that you could perform those discoveries appropriately. So I'm wondering if something in these new capabilities could still do that and leverage, hey, let's collect all the necessary credentials and auth for those, I guess we'll call them legacy by now, right?
Right. And I think the key thing there is you could potentially tweak the pattern to say, hey, in my network scan, I found these IPs that look like Kubernetes API endpoints, and then kind of tweak another process to try and go get credentials for those, but it would be effectively sort of rolling your own.
Yeah, and I don't know how many orgs are scanning their IPs for exposed endpoint, IPs for cloud, but yeah, I hear
almost nobody's even doing horizontal scans in cloud anymore.
Right, exactly.
Which actually, if you haven't looked at it, go look at the AWS Service Graph connector. We now have the ability to ingest data from systems management, right? So if you're running SSM agents on your EC2s, it's a big step forward for us.
Yep, that has to be enabled, I believe. Yep.
All right. Thanks for the questions. B, thanks for the responses to the polls. We super greatly appreciate it. And we're over time, so we'll hang out. And if you guys have questions, feel free to chime in and hang out. But we also want to be cognizant of your time. If you've got other stuff you need to go and do, please feel free, run on and take care of that.
And this recording will be up on YouTube, and you'll get a follow-up email with the YouTube link. And it'll also we basically have a playlist of all these sessions. So if you are new to the series and want to look back in time and see what we've talked about up till now, that'll be easy to do via that playlist.